Alright, welcome back everybody. In this video we're going to look at the mean value theorem for integrals lesson and the examples that are enclosed in there. We start here with this little definition above of what the average or mean value of a function is. That the average is equal to the quantity 1 over b minus a times the integral from a to b of f of x dx. And I talk a little bit about, an ant farm here. Imagine that we have an ant farm here with all this dirt represented by the function f of x. And if you shook this ant farm and leveled out all the dirt, it might look like something like this. And what we've done is we've taken all this area and we've shaken it out so that it now forms a rectangular area here. And so what's represented here by the purple shaded region is the integral from a to b of f of x dx. And the other way that we can find this rectangle is by looking at the height of this rectangle, which represents the average value, times the width of this rectangle, which is represented by the quantity b minus a. And so, the value of the integral is equal to the average value times the quantity b minus a. And so solving for average value, we get this 1 over b minus a is the integral from a to b of f of x dx. And that's where this formula up here comes from. Alright. Example 1. Find the average value of the function f of x equals 4 minus x squared on the interval from 0 to 3. Does f actually take on this value at some point in the interval? So first we're going to find the average value. And the average value is going to be equal to 1 over b minus a, 1/3, times the integral from 0 to 3 of the function. And so the average value here is 1/3 times whatever we get for this value. And you know what? I'm just going to go ahead and find this value numerically. So we've got 1/3 times the numerical integral of 4 minus x squared with respect to x from 0 to 3. And we get that the average value of this function on that interval is 1. Now the second part of this, it asks, does this function actually take on this value at some point in the given interval? So we're asking, is 4 minus x squared actually equal to 1 anywhere in this interval? And if we solve this for x, we get x squared equals 3. So x is equal to plus or minus the square root of 3. Are either of these values in the interval from 0 to 3? Yes, the positive square root of 3 is. And so does this value actually take on at some point in this given interval? Yes. At x equals positive square root of 3. It does. Okay? This is leading us into our actual piece of theory here, the mean value theorem for definite integrals. If we have a function that's continuous on some closed interval, then we are guaranteed that at some point c in that interval, f of c is equal to the average value. Alright, let's look at example 2. Find the value of c that satisfies the conclusion of the mean value theorem for the function f of x equals x squared plus 2x over the interval from 2 to 5. And so the value of c that satisfies this conclusion means that f of c has to be equal to the average value, 1 over b minus a, so 1 over 5 minus 2, times the integral from 2 to 5 of f of x. And so I'm going to find that average value. I've got 1/3 times the integral of x squared plus 2x with respect to x from 2 to 5. And that value is 20. So we're looking for c squared plus 2c to be equal to 20. Solving this equation, c squared plus 2c minus 20 is equal to 0. I can solve this equation however I choose. It doesn't look like I can factor it, so I'm either going to use the quadratic formula or I'm going to use my graphing calculator. I'm going to go ahead and just do this on my calculator. So I graph x squared plus 2x minus 20, and I'm looking for a solution to this in the interval from 2 to 5. So I'm going to restrict my window to the x values from 2 to 5. And look at this graph, and we see there's my value that I'm guaranteed by the mean value theorem, since this is a continuous function. And I go ahead and find that value, and we get c equals 3.583. All right. And our last example for this lesson comes from free response question number 3 from the 2013 AP Calculus AB exam. We've got this coffee pot. Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t from 0 to 6 is given by a differentiable function c, where t is measured in minutes. Selected values of c of t measured in ounces are given in the table above. Quick little review of a midpoint Riemann sum. Use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of the 1 over 6 times the integral from 0 to 6 of c of t dt. Using correct units, explain the meaning of 1 over 6 times the integral from 0 to 6 of c of t dt in the context of the problem. So we're going to use a midpoint sum to approximate the value of 1/6. So I've got this 1/6 out in front times my midpoint sum. We're doing 3 subintervals of equal length, so the width of each interval is 2. And I need the value of the function at the midpoints. So for the first rectangle, it's going to be at 5.3. For the second rectangle, at 11.2. For the third rectangle, at 13.8. And then I'm going to do all of this calculation. And let's see, that's 25, that's 30.3 when I add all those up. So it's 1/6 times 60.6. And that's 10.1. And now I'm supposed to use correct units. Well, when we have 1 over 6 times the integral from 0 to 6 of c of t, this is 1 over b minus a, because b is my right endpoint, a is my left endpoint, 6 minus 0 is 1/6. And so when we see this 1/6 integral from 0 to 6 of c of t, this is the average amount. It's the average value of the function. So this is the average amount of coffee in ounces in the cup over the time interval (0 is less than or equal to t is less than or equal to 6), where t is measured in minutes. And so when we see 1 over b minus a times the integral of some function, it's just the average value of that function. And that's how we're going to interpret the value of this, or the meaning of this, in the context of the problem. Alright, that's the end of this video and the end of this lesson. See you guys next time. Have a great rest of your day.